Welcome back. In this lecture, we will be understand about work, energy and power. So, before this chapter, we have covered about the force. Generally, four are the four types. Fundamental force, that is, first is the gravitational force, second electromagnetic force, strong nuclear force, fourth weak nuclear force. These are the four fundamental force we had studied. Okay, we have left it strong and weak for an upcoming classes. So, what is a work? Generally, when you have a force, we need to apply it somewhere, and it will be the displace, it will be the changes such position, and that will be the measure in form of a work. So, how will we define the work? Generally, we defined it, the work. How we defined it? Work is defined as the product is defined as the product of force and displacement by it, and displacement, not a distance. Distance is a scalar quantity and displacement is a vector quantity. Defined as the product of force and displacement by it in its direction. In mathematically, we can write it. Work W is equal to force into displacement. Generally, we take as a scalar quantity. So, force, when you applied any object, the F force, and it is going to change its position. When you take in the displacement form, then it is the ds. Okay. So, it is a vector quantity. As we know, force is a vector quantity, displacement is a vector quantity, but work is a scalar quantity. Remember, that is very important for any competitive exams. Most of times in an MCQ you find it that work is a scalar quantity. Which quantity is a scalar quantity? Most of time it's question. Three types. Here we write as the work, energy and power. So any type of energy is a scalar quantity because work is a scalar quantity. What is energy and work relation? Doing of the capability of doing work is energy. It will be stored in form of energy, and that will be discussed in a next topic. Okay, here look at work is a scalar quantity and it is the scalar product of force and displacement. And let's change its situation. Let's magnitude of it and ds, and it's going to cos theta. So generally force is depend on the three parameter: quantity of force, magnitude of displacement, and the direction between direction of force and direction of displacement. Okay. So force work is F as cos theta. So when no work will be done, in which conditions work will be 0? So I told you work is depend only three parameter. So there will be three condition when work will be 0. Let's say first, if it will be the 0, if force is 0, then it will be quantity, obviously work will be 0. But when force will be the 0, but motion will exist. So any object which slip on smooth surface, like when you slip on a table on a table and there is no friction force, then the work will be the 0. Second condition, there is displacement is 0. If force is 0, then work done will be 0. Second, if displacement will be 0, position will be not going to change. When you applied the small force and object will not going to displace its position. Example, when you applied the small force on the wall and wall not going to displace because you have the less when you apply because you applied the less force. So in this case the work done will also be 0. Third condition, direction. Cos theta, cos 90's value, cos 0, value of cos 0 1, cos 90 0, cos 45 1 by root 2. We have a table in mathematics, we have understand about this. Okay, so if we can make the angle cos 90, theta will be 90 degree, then work will be 0. But when will be the direction of theta will be 0? When force, the direction of force is perpendicular to the direction of displacement. It's simpler. When weightlifter take the weight and going to up. So in this case, there is a direct force they applied perpendicular and then displaced to the on the displacement. That's why in weightlifter not doing any work. Second, coolie who take the your bucket bag and he not did any work because bag was not displaced. He was displaced. He walk. But bag, he take the bag from the ground and taken on his head and he not did any work on a bag, he walked. Okay. So in case of coolie, there was no work done. So there is a 3 condition when work will be the 0. So is it the minimum for work? No. Cos 180 degree, what will be the value of it? It will be the minus 1. Look at it. The minimum work done. When will be the minimum work done? W is equal to F ds cos 180 degree. And it will be the W is, suppose it as is equal to minus W. When it will be the 180 degree? If you applied force in X direction and displaced in a Y direction. And that's the direction, this is angle. If you applied force here and displace it here, applied here and displace it, it means we applied force here and it's going to here. Look, we are applied here and it's displaced here. Going to here, so direction and displace and direction, the direction between the displacement and direction is the 180 degree, and in that case the work done will be negative and that is will be the minimum work done. So what will be the maximum? So we can look at the maximum work done. Maximum work done when F as cos 0 degree, and that is a Fs. When will be the 0? Applied the force in X direction, the object will displace in the X direction. This is the same direction of the force. Suppose here is the object, we applied the force and it displaced from here to here. It is in the same direction, then theta will be 0 and then work done will be the magnitude of force, applied force and magnitude of the distance, displacement. So it will be the maximum. And when will be the minimum? When applied the force in his direction and the object was displaced here. Okay, when will be 0? When force will be 0, applied force is 0, when displacement, when object is not displaced, when angle between the displacement and the force is the 90 degree, then the work will be the 0. Let's look the relation between the energy. What will be the energy? Energy is defined as a capability of, defined as the ability of doing work, ability of doing work. And how will we measure it? Let's look. So if any object, first let's look at the relationship between the work and energy. You will easily understand and then we will comment. So, work energy relationship. We know about work is the F into ds cos theta. What is energy? Ability of doing work. In which form? Mechanical form work, thermodynamical form of work. We are applied the force by the hand. We are using the different of. If we change the nature of force, we will find the different type of work. If we given the energy heat in form of heat, we will get the energy. Work will be in the different form. Okay, so if you change this force nature of force, you find the different form of energy. Energy is different form, many of form, like nuclear energy, chemical, mechanical. Mechanical energy is two types. Mechanical energy, it is two types. First, it is the one as the potential energy. Second, kinetic energy. We are generally know about potential. What is potential energy? When any object have a capability at any of its specific position, then it will be the potential energy. I told you this is the potential energy. Okay. Generally we represent U, that is we need to force and displacement. So force is the mgh, that is the potential energy. The energy due to is the object at a specific position. The energy due to the motion of object will be defined as the 1/2 mv square, and it is known as the kinetic energy. What's the relation between the energy and work? So look, it is this. W is equal to F ds and kinetic energy is equal to 1/2 mv square. Let's change it the momentum. Okay. And ds over dt.